Alright, time for our video quiz study guide. So, if you don't get this joke on the front thing, you need to study until you find it to be funny. But it's the 8 saying, this guy just goes on forever talking to pi, because he's irrational. Alright, so the real number system. I'll go through this real quick. All numbers in the real number system can be written as decimals. Okay? That's what makes them a real number. If they have a decimal expression, a decimal expansion, they are considered real numbers. The real number system is made of two groups, rational and irrational. The rational numbers can be written as a fraction. So if you see a fraction, that's a big red flag that it's a rational number. But also remember that numbers like 5, which we don't think of as a fraction, I could actually write that as 5 over 1, which qualifies it as a rational number as well. And if we turn them into decimals, they will do one of two things. They will either terminate or they will repeat. So decimals like 6.2 terminates or 7.3 repeating, those would also be rational numbers. Irrational numbers cannot be written as fractions. As decimals, they do not terminate or repeat. They go on forever with no pattern. It's a typo there I need to fix, with no pattern. All right, true or false? What I want you to do here, I'm going to reveal the question. I want you to pause the video and think about it, and then check your answer. Rational numbers can be expressed as fractions. That is true. As a matter of fact, that is the definition of rational numbers, is that they are numbers that can be written as fractions. Irrational numbers have an integer form. Pause it and answer. That is false. Okay? Integers are part of the rational number set. If you remember your little diagram with the circles and the snow cones, we've got integers, and then inside of that is rational, but the irrational are the completely separate things. So if an irrational number had an integer form, well, that would mean it would be a rational number. So irrational numbers do not have an integer form. Irrational numbers do not have a decimal form. All right, that is false. Remember, we talked about on the previous slide that all real numbers have a decimal form. Because irrational numbers are part of the real numbers, they have to have a decimal form. And they do. That decimal form just goes on and on and on forever without repeating and without stopping. 4. Irrational numbers in decimal form do not repeat or terminate. And that is true. Okay? Irrational numbers, if you turn them into a decimal, they are not going to repeat, and they're not going to terminate. They're going to go on and on forever, just random digits. And the last one, for a number to have a decimal expansion, it must be a real number. And that is true. Okay, that is the definition of the real number system, is it's all the numbers that have a decimal expansion. All right, modeling the real number system. Okay. You've also seen the ice cream model. This is just another way to do it. So in the natural numbers, we've got numbers like 1, 2, 3, 4, 5, 6, on up to infinity. You're counting numbers. Whole numbers. The only difference between whole numbers and natural numbers is 0 is part of the whole numbers. Integers. We get the negative whole numbers. So -1, -2, -3, all the way down to negative infinity, 0, 1, 2, 3, 4, all the way up to positive infinity. But still at this point, we have no decimals, we have no fractions. When we hit rational numbers, that's where we start running into fractions. Okay? And then again, fractions, if you turn them into decimals, they will repeat or they will terminate. So rational numbers are fractions and decimals that terminate or repeat, in addition to the integer whole number. Remember, if you are a natural number, you're also a whole number. If you're a whole number, you're also an integer. If you're an integer, you're also rational. And then the irrational numbers would be pi and the square roots of non-perfect squares. So for example, maybe the square root of 20. All right, again, pause it, answer the question, and then we'll check it. So what sets does negative 20 belong to? All right, negative 20, because it's a negative number, and it's a negative whole number, it's an integer. And if it's an integer, that means it's also rational, which means it's also a real number. Give an example of a rational number that is not an integer. All right, for this one, any fraction would have worked. Any fraction, 3/4, 5/8, or any decimal that repeats, 7.4 repeating, or any decimal that terminates would have worked. Is the square root of 97 rational or irrational until y? Pause it and think about it. Square root of 97 is irrational. Why? Because it's a non-perfect square. Give an example of an integer that is also a whole number. All right, for that, anything from 0 up would have worked. 0, 1, 2, 3, 4, so on. As long as it's a positive whole number or 0, it would be an integer that is also a whole number. All the whole numbers are also integers. And the last one there, what sets does 9 belong to? Well, 9 belongs to the natural numbers, the whole numbers, the integers, the rational, and the real. Okay, we know it's a natural number because it's one of our counting numbers. And if you're a natural number, you're automatically whole. If you're whole, you're automatically an integer. And if you're an integer, you're automatically rational. And if you're rational, you're automatically part of the real number system. All right, estimating square roots. Estimate the square root of 23 and plot on a number line. So I need to make a list of my perfect squares and find where 23 is in between on that list. So just knowing them in my head, I know 4 squared is 16, and 5 squared is 25. So 23 is in between 16 and 25, which means that the square root of 23 will be in between the square roots of 16 and 25, which is 4 and 5. Now all I have to do is figure out which one it's closer to. So to do that, I think about, okay, I am 2 away from 25. 23 is 2 away from 25. However, it is 7 away from 23. So it is definitely closer to 25. So if I'm plotting this on a number line, 3, 4, 5, 6. I'm going to plot it in between 4 and 5, but I'm going to put it closer to 5. All right. Estimate the square root of 60. Take a minute and try it. Okay, I know that 7 squared is 49, 8 squared is 64, so it's going to be between 7 and 8. And 60 is 4 away from there, but it's 11 away from there, so it's going to be closer to 8. Square root of 60. All right, and then the final one, estimate the square root of 7 to the nearest tenth. So before I can estimate to the nearest tenth, I've got to estimate to the nearest whole number. I know that 2 squared is 4, and 3 squared is 9. So I know it's between the whole numbers 2, 3. So now I start thinking about the tenths in between there. So 2, that would be 2.0, 2.1, 2.2, all the way up to 2.9. Okay, well 2 squared we know is 4. 3 squared we know is 9, so now I've got to look at the squares of these numbers in the tens place. All right, now 7 is 3 away from 4, and it's 2 away from 9. So I know it's going to be closer to 9 by just a hair. So right in the middle would be 2.5. So since I'm a little bit closer to 9, it's probably going to be somewhere in this area. So I'm going to start with 2.7. So I'm going to do 2.7 squared and see what I get. 7 times 7 is 49. 9, carry my 4. 14, 4, that's 18, 0. 4, 1, 2 times 2 is 4, plus 1 is 5. So 9, 2, carry my 1, 6, 7. Move my decimal number twice, so 7.29. So that is a little bit too big. So now I need to go one smaller, which would be 2.6. So let me make some room here. So if I do 2.6 squared, 6 times 6 is 36, carry my 3. 6 times 2 is 12, plus 3 is 15. Put down a 0. 2 times 6 is 2, carry my 1. 2 times 2 is 4, and then 5. Add that together, 6, 7, 6. So 2.6 squared is 6.76. So 7 is in the middle of those two, but we got to figure out which one it's closer to. So again, I think about money. If I went to the store and I bought something that was $6.76 and I gave them $7, I would need to get back 24 cents and change. But if I went to the store and I only had $7 and I wanted to buy something that was $7.29, I'd be 29 cents short. So it's just a little bit closer to 6.76. So our answer would be that it's between 2.6 and 2.7, but it's closer by just a little bit to 2.6. All right, if you can do all of those, you should do pretty well on the quiz tomorrow.